T minus 15 seconds. T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff of Falcon 9. Go SpaceX, go Cat 502. Vehicle's pitching downrange. Stage 1 propulsion is nominal.
At T plus 30 seconds into flight, Falcon 9 has successfully lifted off from SLC-4E at Vandenberg Space Force Base in California. We're currently throttling the booster's engines down to prepare for max Q,
power and telemetry
the
nominal.
point of maximum aerodynamic stresses on the vehicle. Max Q is reached when the air density of the atmosphere decreases faster than the increasing speed of the rocket.
Falcon is supersonic.
And there's that call out for max Q.
Max Q.
There's a call out for max Q. From here on, even though the velocity is rapidly increasing, the atmospheric density is rapidly decreasing, resulting in less loads on Falcon 9.
And coming up shortly, we're going to have several events happening in rapid succession. In order, these are MECO, stage separation, stage 1 flip, second engine start, or SES1, the boost back burn, and fairing deploy. Main engine cutoff, or MECO, is where all 9 Merlin 1D engines shut down to slow the vehicle down in preparation for stage separation when the first and second stage separate. The stage 1 flip is when the booster turns itself around. We'll then see the boost back burn of the first stage, where the booster engines relight to send the booster back towards LZ4. And in parallel, the MVAC engine on the second stage will light, which will be called out as second engine start 1, or SES1. Now, this engine burn lasting several minutes will propel the second stage and the payload to orbit. And then finally, we will see the payload fairings jettison away from the vehicle. Now, that's a lot of major milestones, and we should see that sequence of events start in just a couple moments.
MECO.
Separation confirmed.
MVAC ignition.
Stage 1 boost back startup.
And there we had that sequence of events. Next up will be the fairing separation, happening in just about 15 seconds from now.
Fairing separation confirmed.
And there you heard and saw those 6 events that happened back to back, including main engine cutoff, stage separation, stage 1 flip, second engine start 1, and the boost back burn and fairing separation. And that boost back burn is scheduled to conclude in a few seconds here.
Stage 1 boost back shutdown.
And right on cue, another engine cutoff on the booster and completion of that boost back burn. The next major milestone coming up is the entry burn on our Falcon 9 first stage, which is scheduled to occur at the 6-minute, 13-second mark. The entry burn is used to slow the first stage during atmospheric re-entry as it heads towards landing zone 4 at Vandenberg Space Force Base in California.
Now, we're currently in our first MVAC burn, which should last another few minutes, and you can see the MVAC engine there on the right-hand side of your screen. Now, today, the Falcon 9 booster, which is on the left-hand side of your screen, will be performing 3 burns in order to land. Now, we just observed the boost back burn, and as Nathan mentioned, next up will be the entry burn. Now, the entry burn slows the vehicle down just before it hits the denser parts of the Earth's atmosphere. And without this burn, we would only be using the atmospheric drag to slow down Falcon 9, which would add extra stress to the vehicle.
Now, following that entry burn, the booster will then initiate its final burn, the landing burn, to slow the vehicle's descent and allow for a soft touchdown on the landing zone. Now, when that Falcon 9 fires up the center M1D engine for re-entry, the vehicle will be flying through Merlin's exhaust gases, also known as the rocket's plume, which deposits a layer of soot on the vehicle's surface. And you have seen these marks across the flight-proven Falcon 9 first stage fleet. That soot comes from the carbon-based fuel that Falcon 9 uses, and with each flight, the soot builds up a little more on the outside of the vehicle. As we mentioned earlier, this booster, including today's flight, has flown over 30 times, and that awesome flight history also means that this booster has a substantially sooty exterior.
Now, on our Falcon 9 booster, attached to the very top are 4 titanium hypersonic grid fins, and those help steer the first stage as it returns to Earth. And when the booster is on screen, you may also see white puffs coming off of the Falcon 9, and those are cold nitrogen gas thrusters, which aid in attitude control.
We are moments away from the beginning of that entry burn. You should see the graphics at the bottom of your screen light up as the engines do on the bottom of your screen. We're about 10 seconds away from that entry burn startup.
Stage 1 entry burn startup.
There's a call out for that entry burn startup on the Falcon 9 first stage. This burn is set to last only 11 seconds, and again, it's just slowing down the vehicle in preparations for its final burn.
Stage 1 entry burn
and
shutdown.
And that concludes our entry burn.
Now, as mentioned earlier, we will be attempting to recover this booster, and today we'll be targeting a landing at landing zone 4 at Vandenberg. And you can follow along with the burn via the engine graphic at the bottom left
Stage
hand.
1 FTS is saved.
And good news there, you can follow along with the burn via the engine graphic at the bottom left-hand corner of your screen. Now, as this burn happens, you'll notice a decrease in both speed and altitude, as well as see which engines are being relit. And this is coming up in just about 15 seconds from now.
Stage 1 transonic.
ISI 1 deploy confirmed. Loft Earth Daily 5 deploy confirmed. Loft Earth Daily 6 deploy confirmed. EO 15 deploy confirmed. Loft Earth Daily 2 deploy confirmed. Loft Earth Daily 3 deploy confirmed. EO 11 deploy confirmed. Loft Earth Daily 4 deploy confirmed. Loft Earth Daily 7 deploy confirmed. All deploys from deploy event 3 successful.
And with that confirmation, we have successfully deployed all 45 payloads tonight. Now, it has been a long mission, but so worth it to see all of those missions now in space. We would like to thank Korea Aerospace Industries for entrusting us with their spacecraft today, as well as all of our rideshare customers on board.
We also want to say thank you to the Range and Federal Aviation Administration for their support, and to you,